Hey guys, in this video we're going to talk about linear functions in the real world. Alright, so now we're going to take what we've learned about linear equations, so equations in the form y equals mx plus b, and see how the m and the b correspond to real world situations. So let's say that a slice of pizza costs $3. If you buy one slice, how much will you spend? So if we say x is the slices, and y is how much money you spent. If you buy one slice, you spend $3, right? So that's the correspondence there. How much will you spend if you buy two slices? 3 slices, x slices. So if you buy 2 slices, you're going to spend, well, they're $3 a slice. 3 plus 3 is 6. If you buy 3 slices, you're going to spend another $3. So you're going to spend $9 in total. What about x slices? What does that mean? So that's just going to be a placeholder, right? X is a placeholder. And, we can generalize this table. So the idea is, we can see that as we're increasing by 1 here, the price that we're paying is increasing by $3. Makes sense, right? So our corresponding equation can be y equals 3x, where x is the slices of pizza that we buy and y is going to be the amount of money that we spend. So the answer here for x slices is you're spending 3x. Right? 3 times x. That's the relationship between the amount of slices that you buy and how much you spend. And this is a linear equation. Okay, so the idea here again with this table representation is if we're increasing by a set amount in the y value for every x, then it's linear. Okay, so that is the idea there. Okay, so this is how the input and output are related in linear equations. So again, as the input increases by 1, the output increases or decreases by a set amount. That's what makes it linear. So in our pizza example, that set amount that we were increasing by for every 1 unit was 3. Okay? So consider this other linear scenario. Let's say that you start out with $100 in a savings account, and each year you earn $20 in interest. So again, just to see this, we could make a little table where x could be the years, and y could be the amount of money in your account. So at year 0, before you start collecting interest, you're going to have $100. That's what it tells us. You start out with $100. Now, after a year goes by, you should have $20 plus the 100 in there that to start out with. So after 1 year goes by, you have $120. After 2 years go by, assuming that you're not adding any more in there, you're just getting that set 20 every year. After 2 years go by, you should have $140. And so forth and so forth. So this is a linear situation because as our independent, sometimes we call it an independent variable x, as x increases by 1, y increases by 20. So this is a linear situation. All right, here's another linear situation. Let's say that a car costs $25,000 when bought new. Its value depreciates by $2,000 every year. So in this case, it's decreasing by a certain amount per year. So again, we can do a little table. So again, x is going to be time, so we can think of that as the years that go by. And y is going to be the amount of money that our car is worth. So at year 0, when you buy the car new, it's worth $25,000. And it's going to depreciate by $2,000 each year. So after a year goes by, it's now going to be $25,000 minus $2,000, which is $23,000. And after another year goes by, we're going to decrease again by $2,000. So 23,000 minus 2,000 is 21,000. And so forth and so forth. So the pattern here, we see that as we're increasing our years in units of, as we increase our year by 1, our value is decreasing by 2,000. Okay, so if you were to write an equation for this, well, we have our y-intercept is our starting value, that's b, that's where x is 0. So our y-intercept is 25,000, and our slope is going to be how much we're increasing or decreasing by, and that's going to be minus 2,000. So an equation that could represent this linear situation is y equals negative 2,000x plus 25,000, where minus 2,000 is the slope and 25,000 is the y-intercept. Sometimes we call the y-intercept the starting value because it's basically what we start with at year 0 or whenever x is 0. Okay, so is this linear or nah? So for every minute that passes, 4 liters of water leak out of a tank. There's initially 100 liters of water in the tank. Is this a linear situation? Well, I would think yeah, because per unit of time, so yes, so per unit of time, so x value, per unit of time, we are decreasing by a set amount, right? And that set amount is 4 liters, right? After every minute that passes, 4 liters leaks out of the tank. And initially, there's 100 liters, so that right off the bat tells us that our initial value, aka our y-intercept, is 100. And we can make a little table for this where, x is usually going to represent your time. So here, our unit of time is minutes. So x is going to be in minutes that pass, and y is going to be in liters. Okay, so, after no time has passed, at 0 minutes, that's our starting value, we have 100 liters in the tank. Okay, after a minute passes, now we're going to take away 4 liters from that 100. So 100 minus 4 is 96. After 2 minutes, again, another 4 liters leak out, so 96 minus 4 is going to be 92. And the pattern is going to continue like this. So again, we can see that this is linear because we're increasing by 1 in the x column, and we're decreasing by 4 in the y column. So our equation for this scenario, we could have y equals m, which is our constant increase or decrease. Here it's negative 4, so we have negative 4x, plus, what's our y-intercept? Well, our y-intercept is our starting value of 100. Okay, that's when x is 0. So this could be an equation that represents this linear situation. Okay, so for this situation, we have a substance that increases in weight by 10% every day, and initially it weighs 400 pounds. So we want to ask ourselves, is this a linear situation? Well, we're given this initial value of 400 pounds, so that could potentially be, a y-intercept here. So if we make a table for this situation, x, again, is typically time. So here, our time is in days. We can see that. So x is going to be in days, and our y value is going to be in pounds, how much this thing weighs after a certain number of days. So at day 0, our initial value is telling us that it weighs 400 pounds. After a day, it's going to weigh 10% more. So 10% of 400 is 40, right? And so, if we add on 40 there, we get 440 for day 1. So on day 2, it's going to increase by 10% from the previous day. So 10% of 440 is going to be 44, right? So we're increasing by 44, so this is plus 40, and here we're increasing by 44, so that's going to be 484. And we can already see that because these two numbers are different, this is not linear. Okay, so even though we're increasing by the same percentage, increasing by the same percentage doesn't mean increasing by the same amount. Okay, so as we can see here, 40 and 44 are two different amounts, so this thing is not linear. Okay, what about this situation? At a video game rental store, members rent Nintendo games for $2 a night, and the club charges a $20 annual membership. Is this a linear situation? Well, let's make a little table again. So what would X and Y be? Think about that. So X is going to be time, right? So X is going to be, how many nights, right? Because it says that we're renting for $2 per night. And the club charges a $20 annual membership fee, so we can say that, Y is going to be how much money we're actually paying this video game rental store. So if we, if X is 0, right, we're not renting a video game for any amount of nights. All we're paying is the $20 annual membership fee. Okay. If let's say that we rent video games for one night. So at one night, how much are we paying? Well, we're going to be paying the membership fee plus $2, right? Because we're only renting it for one night. So 20 plus 2 is going to be $22 that we're paying. And in a similar way, if we rent it for 2 nights, $2 per night is going to be 4 plus the original 20. So that's going to be $24. And we can see that this is indeed linear because as X is increasing by 1, as the nights increase by 1, the amount that we're paying is increasing by 2. So yes, this is linear, and our equation would be y equals, our set amount is 2, so that's going to be our slope, 2x, plus, and the y-intercept is the amount that you're initially paying before we start, putting in x1, x2, x3, etc. So the initial amount is going to be $20. That's our y-intercept. And that is our equation that represents this situation. Okay. So, real world situation. Let's go ahead and read what we have here. So we have, the basic idea is to look at these situations in 3 ways. In the situation itself, like what is the situation? Can you describe it with words? Can you describe the situation with an equation? And can you describe the situation with a table? So we're going to practice going between these 3 methods. So first of all, we're given an equation for this situation. Okay, we're given that our slope is 3/4 and that our y-intercept is 4. Can we fill in the blanks here with that information? It says your 3-year-old brother originally had some amount of money, some amount of dollars in his piggy bank. He earns some amount per week for doing his chores. So what's going to go in which blank? The y-intercept being 4 and the slope being 3/4 is going to go in one of those. Well, the y-intercept is always going to be your starting value. So because it's saying that he originally had some amount, that's going to be our y-intercept. Goes in this blank. So our y-intercept here is 4. So he originally had $4 in his account. Now what goes in the next blank is how much we're constantly changing by. That's our slope. So it says he earns blank per week for doing his chores. How much are we changing by is this guy right here. So 3 over 4 in dollars is just 75 cents. So this little kid is getting gypped, probably because he's 3. I don't know. But the idea here is that m is 3 over 4, which is equivalent to 75 cents, because we're talking about a real world context here. So he's getting 75 cents per week for doing his chores. All right, so we've just translated this equation into this real world scenario. And now we can go back to the table and plug in some values. And to do that, we can just use our equation, right? So it says, okay, so what's the value of y when x is 0? Well, that's the starting amount. If we were to plug in 0 for x, we would get 3/4 times 0 plus 4. Anything times 0 is 0. 0 plus 4 is 4. Okay, so y is 4. If we plug in 4 for x, we get 3/4 times 4 plus 4. 3/4 times 4, if you verify that over here, those cross out and you just get 3. So this is 3 plus 4 is 7. Okay, so this is 7. All right, and when x is 8, we have 3/4 times 8 is 6 plus 4 is 10. When x is 12, we have 3/4 times 12 plus 4 is 9 plus 4 is 13. All right, and when x is 16, we have 3/4 times 16 plus 4 is 16. Okay, and so we can, interpret this. We can say, okay, well, week 0, he had $4. After 4 weeks, he had $7. After 8 weeks, he had $10. After 12 weeks, he had $13. And after 16 weeks, he had $16. Okay, so it says, after doing his chores for 6 weeks, how much money will he have in his bank account? So we have this equation that tells us everything we need. It says, after 6 weeks, how much will he have in his bank account? Well, x is going to represent time, which is weeks in this case, and y is going to represent how much money he has. So what we're just doing here is plugging in 6 for x to see what we get out for y. So when we do that, we get y equals 3 over 4 times 6 plus 4. And that is going to simplify, let's see. So 6 times 3 over 4 plus 4. So it's going to have $8.50. And that's our answer there. Okay, so it says your brother has $13. How many weeks has he been doing his chores for? All right, well, this time we're given a y. So we're given that y is $13, and we're asked to find how many weeks this corresponds to with our function. So we can see in the table already that it should correspond to 12 weeks, right? Because we have $13 for y, 12 for x. But let's verify that with the equation. So we have y equals 3 over 4 x plus 4. We're plugging in 13 for y, and we're solving for x. So we have 13 equals 3 over 4 x plus 4. If I solve for x, I can first subtract 4 from both sides. And we get 9 equals 3 over 4x. And now to get rid of that 3 over 4, I can multiply both sides by 4 over 3. And I should get my x this way. So x is going to be, well, if I multiply these and cross simplify, 3 goes into itself once, it goes into 9 3 times. Multiplying straight across, I get 12. So the answer here is 12 weeks. And again, we did see that from the table in this row right here. You buy a saguaro cactus 6 feet high and it grows at a rate of 0.2 inches every year. So assuming that this is linear, right? Because, I mean, they are telling us that it's growing by a set amount each year. We can make an equation for this and we can answer both of these questions. How tall it's going to be after 10 years and how long it's going to take to grow 10 feet. So, first thing I would do is I would put everything into inches. So, we want to ask ourselves, what is 6 feet in inches? Well, we know that there's 12 inches in 1 foot. So, you know, if we want 6 feet over here, if we multiply both sides by 6, we get this new equality. We get 6 feet is equal to 6 times 12, which is 72 inches. All right, so 6 feet is 72 inches. So, you know, because you always want to be in the same units when you're doing problems like this. So this is secretly 72 inches. And we can go ahead and make a table for this. So we have x and we have y. And what does x represent and what does y represent? Well, x is time. So here our time unit is in years. And y, the output, is going to be how tall the cactus is, right? And that's going to be in inches. So at year 0, how tall is it? Well, it's 6 feet high, which is 72 inches. So when x is 0, y is 72. Now the rate is the slope, right? How much it's growing per year. So after 1 year, it's going to have grown another 0.2 inches. So 72 plus 0.2 is just 72.2. After 2 years, it's going to be 72. So again, we're adding 0.2 to that to get 72.4, and so forth. At this point, we can make an equation, because all we need to make an equation is the slope and the y-intercept. So what's our slope? Well, our slope is that constant rate of change per year. So as we're increasing by a year, how much are we increasing for y? Well, we're increasing by 0.2, right? So m is going to be 0.2, and b is the starting amount, so how tall the cactus was, and that's 72. So our equation is y equals m, which is 0.2, x plus 72. And once you have an equation, you can answer any kind of question, right? So the first question is, how tall is it after 10 years? So that corresponds to x being 10. What is y? So when x is 10, what is y? Well, we just plug in 10 into this function. We get y equals 0.2 times 10 plus 72, and we can evaluate that in our calculator or in Desmos or by hand if you want. But it's going to be 74, right? When you evaluate that. So this is going to be 74 inches. So that's our answer for the first question. This is going to be 74 inches. And the second question says, how long, so we're looking for x, because we're asking how long, it's a unit of time, will it take to grow 10 feet? So here, y is 10, and we're looking for x. So when y is 10, what is x? Well, if we just plug in 10 into this equation, we get 10 equals 0.2x plus 72, and we can solve for x this way. So if I first subtract 72 from both sides, I get minus 62 equals 0.2x, and then I can divide both sides by 0.2 to get x alone. Oh, you know what? I made a mistake here, because now I'm going to get a negative number, which doesn't even make sense, right? Because x can't be negative. What did I do wrong? Well, this is the classic mistake. I didn't put feet into inches. I need to do that first. That's why I'm getting weird answers. So let's go back. So we had y was 10 feet. So y is equal to 10 feet. We know that there's 12 inches in a foot. So y is 10 times 12, which is 120 inches. And now this should make sense. So if we plug in 120 into this equation for y, we get 120 equals 0.2x plus 72. And then I can solve for x by subtracting 72 from both sides and dividing by 0.2. So we get 48 is equal to 0.2x, dividing both sides by 0.2. I get 240. And this corresponded to years. So this is going to be 240 years is our answer for the second question. Okay, let's look at this next example. A cab company charges $2 for passengers to get into the vehicle. They then charge $1.50 for each mile the cab goes. Okay, so we want to first write a linear equation to match the situation so that we can answer these questions down here. And we'll graph it too. We'll graph the equation too. Okay, so we have these two numbers and we want to know which one is the slope and which one is the y-intercept. So the slope is the amount that's changing per x. In this case, our x is miles because it says for each mile. So if we make a little table here, we have our x. This is going to be in miles, not time this time, which is okay. We can have that. And y is going to be the amount that we're paying. So so it says the company charges $2 to get in the cab. Well, that means that at 0 miles, that person is being charged $2. Okay, and then after every mile, they're charging $1.50 extra. So after 1 mile, it's going to be 2 plus $1.50, which is $3.50. After 2 miles, another $1.50 gets added to that, so that's $5, and so forth. So we can see what the pattern is here, and we can write an equation. So as x goes up by 1, y is going to go up by 150. And we can see here that our slope is $1.50, so m is 150, and b is going to be the y-intercept. So when x is 0, so that's 2. So our equation is y equals 150x plus 2. And we could graph this if we wanted to. So we have some points here to graph this. So when x is 0, y is 2. So that would be our first point right there. When x is 1, y is 350. So when x is 1, y is 1, 2, 3, between 3 and 4, so maybe right here. And we just need 2 points to plot a line, so we can just draw our line through those points like that. And now that we have an equation, we can answer these questions down here. So it says a person needs to go 4 miles. How much will they end up paying? So again, x is miles. So in our equation, y equals $1.50x plus 2, we're going to plug in 4 in for x because x represents miles. So we have y equals $1.50 times 4 plus 2. So that's going to be 8. That's going to be $8. All right, so that's our answer here. A person spent $5. How many miles were they in the cab for? Well, this time our y is given. We're looking for the miles, so we're looking for the corresponding x when y is $5. So again, using this equation, y equals $1.50x plus 2, we can plug in 5 for y and solve for x. So if I subtract 2 from both sides, I get 3 equals $1.50x. Dividing both sides by $1.50, I get x is equal to 2. So they were in the cab for 2 miles.